The ability of a material to let heat or electricity pass through. Conductivity. Conductivity is how well a material allows heat or electricity to flow through it. Imagine you're trying to transfer a phone call through a series of people in a game of telephone. Just like how the message needs to pass clearly and quickly from person to person to maintain its original intent, conductivity describes how efficiently heat or electricity can travel through a material. In this analogy, each person represents a particle within the material, and the clarity and speed of the message passing through them represent the material's ability to conduct heat or electricity effectively. Elements in the same vertical column of the periodic table. Group. In science, a group is a column of elements in the periodic table that have similar chemical properties. Imagine trying to organize your kitchen pantry, where you group all similar types of canned foods together on the same shelf. This is similar to the periodic table, where elements in the same vertical column, or group, share similar chemical properties. Just as each shelf is dedicated to a specific type of canned food, like all soups or all beans, each column in the periodic table contains elements that behave similarly in chemical reactions, making it easier to predict their behavior, just like you can easily find what you're looking for in your pantry. An element in group 17 of the periodic table, like chlorine. Halogen. Halogens are reactive nonmetals that can form salts when combined with metals. Imagine you're at a party, trying to find the perfect spot to join a conversation without feeling left out. Halogens, like chlorine, are a bit like that. They're always looking to join in and form bonds with other elements to achieve stability. Just as you search for the right conversation to fit into, halogens eagerly seek out electrons from other atoms to complete their outer shell and reach a stable configuration. This desire to connect and complete makes halogens highly reactive, much like your determination to find your place in the social circle. The way a mineral's surface reflects light. Luster. Luster is how shiny or dull a mineral appears when light reflects off its surface. Imagine you're trying to choose the perfect outfit for a special occasion, but the lighting in your room is too dim to see the true colors of your clothes. This situation is similar to how a mineral's surface reflects light, as both involve the interaction between light and surface characteristics to reveal true appearance. Just as the brightness and angle of light in your room affect how you perceive the colors of your clothes, the luster of a mineral depends on how its surface interacts with light, determining whether it appears shiny like a polished shoe or dull like a well-worn sweater. An element in group 18 of the periodic table, like helium, neon, and argon. Noble gas. A noble gas is a chemical element with a full outer shell of electrons, making it very stable and unreactive. Imagine trying to fit in at a party where everyone already knows each other, and you feel perfectly content just observing without joining in. This scenario is much like the behavior of noble gases, such as helium, neon, and argon, which are content to remain inert and unreactive. Just as you might feel no need to interact because you're already stable and comfortable, noble gases have complete electron shells, meaning they don't seek out reactions with other elements, staying content in their balanced state. A unit of geologic time that lasts tens of millions of years, it is longer than an epoch, but shorter than an era. Period. In science, a period is a time frame in Earth's history marked by specific geological and climatic conditions. Imagine trying to organize your family photo albums where each album represents a different stage of your life, like childhood, teenage years, and adulthood. Each album is like a geologic period. It encompasses a significant amount of time and contains many individual events or photos. but it is part of a larger collection of albums that represent your entire life, similar to an era. Just as a family photo album captures a specific, substantial phase of your life with many memorable events analogous to epochs, a geologic period captures a broad and significant span of Earth's history, organizing it between the finer details of epochs and the grand scope of eras. The breakdown of an unstable atomic nucleus, this releases particles and energy. Radioactive decay. It's a process where unstable atoms release energy and particles to become more stable. Imagine you're trying to clean out an overstuffed closet, where things keep falling out every time you open the door. Much like how that closet can't stay closed without releasing some items, an unstable atomic nucleus can't remain intact without releasing particles and energy. Just like those items need to fall out for the closet to become more stable, radioactive decay involves the nucleus shedding particles to become a more stable form, with the items being analogous to the particles and energy emitted during the process. The ability of an unstable nucleus to emit radiation. Radioactivity. It is the process where unstable atoms release energy in the form of particles or rays to become stable. Imagine you're trying to balance a stack of books that keeps wobbling because it's not stable. Just like the stack of books, an unstable atomic nucleus is also in a precarious state and seeks stability. In both cases, the wobbly stack will eventually topple over or require you to remove some books to stabilize it. Just as the unstable nucleus achieves stability by emitting radiation in the form of particles or energy, thereby altering its structure. An element that is a good conductor of heat and electricity. Metal. Metals are substances that are typically shiny, dense, and can be molded, often allowing electricity and heat to move through them easily. Imagine you're trying to get a message to your friend quickly by passing it through a group of people. This is similar to how metals conduct heat and electricity effectively, as they have free electrons that can move easily and carry energy swiftly, just like a message passed quickly from person to person. Just as a clear path in a crowd ensures your message reaches your friend without delays, the structure of metals allows electrons to move freely and efficiently, making metals excellent conductors. An element that is a poor conductor of heat and electricity. Nonmetal. In simple terms, a nonmetal is an element that lacks the ability to conduct heat or electricity well. Imagine trying to hold a conversation in a crowded room where everyone is talking at once. Just as it's difficult for your words to reach the person you're speaking to amidst all the noise, a nonmetal struggles to pass heat or electricity efficiently. In this scenario, your voice is like heat or electricity. The crowded room represents the structure of a nonmetal, and the difficulty in communicating mirrors the poor conductivity of nonmetals. An element that shares properties with metals and nonmetals, like a semiconductor. Metalloid. A metalloid is an element that has characteristics of both metals and nonmetals and can conduct electricity under certain conditions. Imagine trying to decide between wearing a jacket or just a t-shirt when the weather is neither too hot nor too cold. This situation is similar to a metalloid, which balances the characteristics of metals and nonmetals, much like how you balance your clothing choice based on the temperature. Just as a jacket might be too warm and a t-shirt too cool, metalloids, like semiconductors, possess intermediate properties that allow them to conduct electricity better than nonmetals, but not as well as metals, perfectly adapting to the needs of electronic devices. An element in group 3 to group 12 of the periodic table. They are all metals. Transition element. Transition elements are metals with unique properties like forming colorful compounds due to their ability to use different electron shells for bonding. Imagine trying to coordinate a large group outing where everyone has different preferences and interests. Transition elements, similar to this scenario, are metals that reside in the middle of the periodic table and serve as a bridge between the highly reactive elements on either side. Just as you need to find common ground to keep the group cohesive, transition elements balance properties such as variable oxidation states and the ability to form various compounds, acting like versatile mediators in chemical reactions. A chart of all the elements arranged by their physical and chemical properties. Periodic table. The periodic table is a grid that organizes all known chemical elements by their properties and atomic number. Imagine trying to organize your wardrobe where you have a mix of clothes for different seasons and occasions. Just like sorting clothes by type, color, and purpose helps you find the right outfit easily, the periodic table arranges elements based on their physical and chemical properties, making it easier to understand how they behave and interact. In this analogy, each type of clothing, like shirts, pants, or jackets, represents different groups of elements, such as metals, nonmetals, and noble gases, and organizing them helps you quickly locate what you need, just as the structure of the periodic table helps scientists find and predict the behavior of elements. Elements in Group 1 of the periodic table, like lithium, sodium, and potassium, are alkali metals. Alkali metals are highly reactive elements that have one electron in their outer shell. Imagine you're at a party, and there's always that one friend who gets the party started, reacting with everyone and everything, making things lively, but sometimes going overboard. Alkali metals, like lithium, sodium, and potassium in Group 1 of the periodic table, are just like that friend, highly reactive and ready to interact with other elements at the slightest opportunity. Just as your lively friend can quickly energize a dull party with their enthusiasm, alkali metals rapidly react with water and other substances, releasing energy and often creating a dramatic effect. A particle consisting of two atoms, a diatomic molecule. A diatomic molecule is a molecule made up of two atoms bonded together, like oxygen O2 or hydrogen H2. Imagine trying to keep two magnets stuck together while they naturally want to either attract or repel each other. This is similar to how a diatomic molecule is formed by two atoms that bond together, sharing or exchanging electrons to maintain their connection. Just as the magnets need a balance of force to stay together, the two atoms in a diatomic molecule need a balance of energy, like a mutual agreement, to remain connected and stable. A material that conducts electricity under certain conditions, it has properties of both metals and nonmetals. Semiconductor. A semiconductor is a substance that can control electrical currents, making it crucial for electronic devices like computers and smartphones. Imagine trying to decide whether to wear a jacket when the weather is unpredictable. Sometimes it's warm and sometimes it's cool. This is similar to how a semiconductor behaves, as it can conduct electricity like a metal when conditions are right, just like wearing a jacket when it's cold, but resist electricity like a nonmetal under different conditions, like not wearing a jacket when it's warm. Just like you assess the weather to decide on wearing a jacket, semiconductors assess their environment, such as temperature or voltage, to determine whether they should conduct electricity or not, balancing between the properties of metals and nonmetals.